Hello everyone, welcome back to our channel. In today's video, we are going to explore Terraform and understand the concept of infrastructure as a code. Well, also walk through the installation process of Terraform on Linux, Windows and Mac and set up a GitHub code space for our Terraform projects. So let's get started. First, let's understand what Terraform is. Terraform is an open source tool created by HashiCorp that allow you to define and provision data center infrastructure using a declarative configuration language known as HCL. It means HashiCorp Configuration Language. But before we dive deeper into, let's discuss infrastructure as a code, which means IAC. With IAC, infrastructure is managed and provisioned through code, which means you can use version control, automate the development process, and collaborate with teams more effectively. In today's video, you will learn introduction to Terraform and infrastructure as a code, installing Terraform process, setting up Terraform for AWS, and etc. Let's visualize this with a simple scenario. Imagine you are a DevOps engineer needing to create an S3 bucket in AWS. Traditionally, you will log in into the AWS console, navigate to the options and manually create the bucket. Let's see the manual creation steps. Log into AWS console, navigate to S3 and create S3 bucket. Now here is the issue. If it takes 2 minutes to create one instance, so creating hundreds of instances will take approximately 200 minutes. That is a significant amount of time when scaling up your infrastructure. To speed up this process, we can explore better alternatives using AWS CLI and API. You can create resources using the AWS CLI. However, this requires some command line knowledge. Alternatively, you can use the AWS API with the programming knowledge, like using Auto3 in Python to automate the creation service like VPC, EC2, etc. So next step is AWS CFT. It means AWS Cloud Formation Template. AWS provides Cloud Formation, which use Cloud Formation Template. These are customizable templates for creating AWS resources in JSON or YAML format. However, they are specific to AWS. In other cloud platforms, for Azure we have Resource Manager template. For OpenStack, there are heat templates. Each of these solutions has its strengths and limitations. Now you might be wondering, why should we use Terraform? Here are few key points. Declarative configuration. You define your infrastructure using code, and Terraform handles the details of how to create and manage it. Second one is provide agnostic. Whether you use AWS, Azure, GCP or other, Terraform supports hundreds of providers. Third step is infrastructure versioning. You can track changes to your infrastructure in the same way you can track changes in code, allowing for collaboration and easy rollback. Fourth step is modular architecture. With Terraform modules, you can create reusable components, speeding up your development time, and etc. In summary, Terraform provides a multi-cloud support, automating the developing of resources across different platforms like AWS, Azure, OpenStack, and GCP. It is designed to be a universal solution, which is why it's currently trending in the DevOps space. Now that we have a basic understanding of Terraform, let's move on the installation process. So we will focus on setting it up in GitHub code spaces, which is available across platform and provides a free usage trial of 16 hours per month. First, let's head over to our GitHub pages. Here you can installation instruction. Here you can see install.md, the installation instruction for Windows, Mac and Linux. Also, you will find the installation files listed for each OS. Make sure to follow the step-by-step instruction provided there to set up Terraform on your local environment. So, open the page, and as you can see, the following commands are for Mac OS and following file for Windows, Linux, and you can choose command according to your Linux. So let's move to our GitHub page, and as you can see, here is the steps. Now let's set up Terraform in GitHub code space. Follow these steps, navigate to your repository and click on code. Then select open with code space. And as you can see, our code space is setting up and it will take us some time. and the GitHub code space allows us to 60 hours per month. So in the code space, open the command palette by pressing Ctrl Shift P and type dev and click to the add dev container configuration file. Choose your active configuration and modify it. In the search bar, type Terraform and select the relevant Terraform, TFLint and Tigran development containers. And here it is verified. So I click on OK. So click on keep defaults. As you can see, the dev container.json file are created. It is just like to attach the plugin of Terraform. After modifying the configuration, check the Terraform version using the command Terraform version. So Terraform command not found. Because it is not installed, you will need to rebuild the code space. Now I will again press Ctrl Shift P and click to the dev container, modify your active configuration and type AWS. You will see AWS CLI dev containers and it is verified. So I am click on this and OK and click to the keep defaults. And as you can see, here is a one more line added into dev container.json. So we can verify with AWS version. Again it will show command not found because we need to rebuild the code space. So type Ctrl Shift P and type rebuild and click to the rebuild container. Press to the rebuild button and our code space is starting the rebuilding. And it will take us some time. So wait for setting up the code space. So as you can see, our code space is rebuilt and set up. Now I will type Terraform version and now it will show Terraform v19.7 on Linux AMD 64. Now we will check for AWS. So type AWS version. As you can see, it will show AWS CLI 2.18.6. It is indicate the our successfully installed Terraform and AWS on our machine. Next, let's configure our AWS credentials. Go to the AWS Management Console, navigate to IAM, and create a new user with programmatic access. So, I will create a new user with name of test and I click the checkbox and I want to create an IAM user. So everything is as it is. Now I am click to the next. Now I will select attach policy directly and search EC2 full access and type AWS full access. Sorry, type S3 full access and click to the next and you can see our console password type is auto generated. Now I'll create a user. So return to user list. So our test user is created. Now I will open the test user and click on the security credentials and scroll down and create access key for command line interface and click to the next. Now I will press the create access key button. As you can see, our access key and secret key are generated. Now let's move to the code space and type AWS configure. Now it will ask for AWS access key. So let's move to the AWS console and copy the access ID and paste here and hit enter. Now it will ask AWS secret access key. So I'll copy that and paste here and hit enter. Now it will ask default username. So I will type US East 1 and hit enter for default and hit enter for default formation and hit enter for default output format. Now I type AWS S3 LS. It will show nothing because I have nothing into my directory. Now let's move to our main.tf file in our directory. So first I will type ls. Let's move to the day 1 cd day 1 and into day 1 let's move to the AWS and type ls, and as you can see our main.tf file are here. Now I run the command terraform init. This command initializes Terraform and downloads the necessary plugins. And it will successfully initialize. Now our next step is check what Terraform will do with. So I will type Terraform plan. This command provides a detailed output of what will be added, changed or removed. And as you can see our plan 1 to add, 0 to change and 0 to destroy. Now as you can see for what Terraform will perform the actions. Now to create the resource, execute the command terraform apply. Now confirm the action when prompted. So I will type yes and it will take some time for creating instance. Now our instance is created by Terraform and let's move to the AWS console and move to the EC2. And as you can see our current running instance is 1. So I'll open that. And as you can see our created instance by Terraform is running, which is a Linux based virtual machine. So when you are done, clean up the resource with Terraform destroy and confirm the action to remove all the resource Terraform created. So I will type yes. Now the instance is successfully destroyed. Our next topic is creating virtual machine or instance into GCP using Terraform. GCP means Google Cloud Platform. Now our topic is GCP. It means Google Cloud Platform. We can configure a virtual machine or instance using Terraform. So let's get started. First of all, open GCP in your browser. Then click on it. Now I will search service accounts and open the service accounts. So as you can see the following users are already created. So I want to create a new service. So now I want to create service account. So click on create service account and type name of service account name. So I will type test and as you can see service account ID is automatically created. Now I will press on create and continue. In the second step you can configure a user role according to editor, owner or etc. according your needs. So I will press continue and I will press done because it is optional. As you can see, our test user is now created. So I pressed actions and manage key. Now I don't have any keys. So I will create and configure it. So I will press add keys and create a new key. And I will download JSON file. And I will download JSON file because we will use into our code space. So I can download and create the JSON file. And press close. As you can see, our JSON file is now created and downloaded. Now let's move to our code space. Now let's move to the code space. Let's move to the code space and configure the Google Cloud. Now I will type into terminal gcloud or login. It will show gcloud command is not found because we don't attach the plugins. Now we need to set or add plugin into our code space. So I will press Ctrl Shift P and click to the add dev container configuration file. Modify your active configuration. Then I will type gcloud. So first option is for Google Cloud CLI. I click into it and OK and press into keep defaults. Now our next step is to rebuild our code space. And as you can see, one more line is added into our dev container.json file. So one more step is I type gcloud. So it will give an error command not found. So what to do? So basically we need to rebuild our code space. So I will type Ctrl Shift P and rebuild container and press into rebuild. So it will take some time. So wait for it for setting up our code space. So my GitHub code space is rebuilt successfully. So I will type for check. So I will type gcloud for checking the Google Cloud CLI is properly installed or not. So our first step is to log in Google Cloud to our code space. So I will type gcloud or so our first step is to connect Google Cloud platform into our code space. So I will type Google Cloud. It means gcloud or login and copy the link and open into your browser where your Google Cloud Console is login. So I will open the second browser where my Google Cloud Console is running. Paste here the link and hit enter. Choose your Google Cloud accounts. Choose your Google Cloud Console account for signing. Now for authentication and signing, and I have a verification code. Copy the verification code and let's move to the code space and paste here. Now we are successfully logging into our Google Cloud Console. Now our first step is to run Terraform. To run Terraform, make sure you have a main.tf file. I have already mentioned into our GitHub repository. So I will move to the cd a1 cd gcp sample and hit enter. Now I type ls. As you can see, my main.tf file is here. So now I will type Terraform init or initialization process. As you can see, the Terraform has been successfully initialized. Now I will type Terraform plan. So it can give an error which is test.json file, and I forgot to add my JSON file. So let's move to the GCP sample and create one file test.json. As you can see, so we now open the downloaded JSON file which is downloaded from here. Now I will open my download section and open this file, and as you can see our JSON file. So I will copy that and move to the code space, paste into test.json. Then I will again run Terraform plan. As you can see, it will run without any errors, and it will show one service to add, 0 service to change, and 0 item to destroy. So it is successfully run, and now I will enter, and now I will type Terraform apply. To this command, we will apply these following services into our GCP and Terraform. So it will ask for actions. So I will type yes. So I will type yes and hit enter. As you can see, the Google Cloud instance is creating our virtual machine. So wait for it for successfully creation of our virtual machine. As you can see, our virtual machine is created successfully into our Google Cloud platform. So let's move to our Google Cloud platform and search virtual machines. And open VM instances. And we can see the one service is running. It means one instance is created and running by Terraform. So the following steps is for creating virtual machine into our Google Cloud platform using a Terraform. Now I will destroy the service. Now after our work has been done, so I will use Terraform destroy for destroying our instance which is currently running, and it will ask for action. I will type yes. Now our Google Cloud platform instance are destroyed. As you can see, our instance is successfully destroyed into our Google Cloud platform. So our next topic is to create instance into our Microsoft Azure using Terraform. So let's move to the next topic. Now our topic is to create a virtual machine or instance into our Microsoft Azure cloud platform. So I am going to create a virtual machine in Microsoft Azure using Terraform. Terraform is a fantastic infrastructure as a code tools that allow you to manage infrastructure in a repeatable and automated way. Let's dive right into it. First of all, ensure you have an Azure account, and you will also need to have a Microsoft and Azure CLI into your local machine or code space. So I don't have any Azure CLI. So let's install CLI by pressing Ctrl+Shift+T and select Add Dev Container Configuration File. Modify your active configuration and type Azure. And as you can see, the Azure CLI is published by Dev Containers. It is verified. So I click on that and OK and press to keep defaults. And as you can see, one more line added into our dev container.json file. It means it successfully installed Azure CLI into our code space. But when I type az, you will see command not found. So So we need to rebuild our code space by pressing Ctrl Shift P and type rebuild and press the rebuild button. And our code space is starting rebuilding and setting up. And it will take us some time. So wait for it for successfully rebuilding and setting up. Now our GitHub code space is rebuilt successfully. Now I type AZ login. It will also indicate the Azure CLI is successfully installed. So copy the link and paste into your browser where your Azure account is login. So paste here and it will ask for code. So copy the code, paste over here, paste the next. Select your account and continue. As you can see, the login is successful. So I will press enter for default. Now we need to create a special principal for our Azure account. So I will type AZ AD SP create for RBS and I will type test Azure. Then type role, type contributor, then type scope, and copy your subscription ID from your Azure console and paste over here. So I'll paste here, then hit enter. As you can see, we successfully find app ID, display name, password, tenant, etc. Now we need to export the following credentials by using these details. So I'll copy that and paste into your client ID and copy password and paste into your client secret. Copy the tenant and paste into tenant ID. So paste the following details over here. As you can see export ARM subscription ID, client secret, ARM tenant ID and ARM client ID. Now I will hit enter. Now we need to locate our main.tf file by typing command cd a1 cd Azure sample. Type ls polish directory. As you can see, our main.tf file is over here. And I will provide this main.tf file into our repository. Now run the following command terraform init and hit enter. Now Terraform has been successfully initialized. So our next step is to type Terraform run. As you can see which service has been added by when we will type Terraform apply to create our infrastructure. I will type Terraform apply for creating instance. Press yes for confirmation. Now it will start for creating our virtual machine or instance into our Microsoft Azure. And as you can see, our instance or a virtual machine created successfully into our Azure account by using Terraform. As you can see, our instance and virtual machine are created successfully into our Microsoft Azure account by using Terraform. So let's move to the Azure console and search virtual machines. As you can see, our test virtual machine is running successfully. So if your work has been done, after your work has been done, do not forget to destroy your virtual machine by using Terraform destroy command. So I will type Terraform destroy and hit enter, and it will start destroying our virtual machine, and type yes for confirmation. Now it will start destroying our virtual machine into our Azure account, and you can see our destroy is completed. You can see our destroy process is completed. You can see our destroy process is completed from our Azure account by using Terraform. And that is how you deploy a virtual machine in Azure using Terraform. We have covered the basics. But there is so much more you can automate and configure using Terraform. So thanks for watching.